There we go. Hello everyone, so today I'd like to share a bit about the compressed air powered gun project I've been working on. And to make one of these, I suppose the air reservoir thing is optional. You can make a version which is just connected directly to an air compressor air line, but this is just it's good to have some sort of buffer at the back, because the pressure drop over an airline when one of these solenoid valves opens up is quite considerable. And this was the old reservoir I was using. It's I think 1-inch copper pipe I made it out of, and that was okay, but I wanted something a bit bigger. So the heart of it is one of these sort of Chinese solenoid valves, and to modify it I just enlarged the inlet port there, and then enlarged the hole there in the middle to 4mm, and once I did that I had to sand it carefully from the top to make the flat area again, so that the valve could seal. In addition to that, I had to rewind the coil on it. So if you look here, the coil is really thick, so I just unwound it across the garden and just went back and forward with it, doubled the strands up on each other 6 times, so it's now just like 6 strands in parallel, and then I just wound them back onto the coil. So at 12 volts this coil pulls about 30 amps, as opposed to I think it was roughly 1 or 2 amps that it pulled originally. And this is not a problem because it's only triggered for an instant anyway, so it never warms up. I'll show you how quick it is anyway. What else do we have? I'm going to put a circuit diagram up anyway, but it's basically a MOSFET based triggering system. IRFB 4110 handles lots and lots of current, no problem. Simple button switch. I was wanting to use an Arduino to do this, and I did give it a try, setting up the delays and the code so I can change how long the solenoid's open for. And I used one of those little buck converter things just to supply 5 volts to the Arduino, and for some odd reason, as soon as I powered it up, pin 13 on the Arduino actually does give out a little pulse, and that triggered the MOSFET, and for some odd reason it just fried the power supply immediately, even though I've got a suppression diode across there to stop high voltage spikes. So I don't know what was going on there, so I just went for a robust analog electronics approach, so no microcontroller. Here is the circuit diagram. So this will be your 3-cell LiPo battery connected here, and when the trigger is fired, you get the small pulse going to the gate of the MOSFET, and that pulse will be however long it takes to the contact in the relay to switch to the unused output pin. So we've got the resistor there. This 10 ohm resistor is just basically to limit the amount of current which flows through the trigger switch, and to protect its contacts, because charging up a big capacitor like that instantly creates a little bit of a spark, and that would eventually damage the contacts. And those connections there are just for the coil of the relay. And as you can see from the diagram, it's a fairly simple system, and a good way of generating an instantaneous pulse for anything using just analog electronics. Well, I suppose you could count the relay itself as maybe a mechanical piece of electronics. It fires 10.5mm plastic 3D printed bullets, and I've lost half of them in the garden, so that's not so good. The barrel for it, I'll try and find that just now. This is the barrel. 15mm aluminium tube, and it's obviously not rifled, but it's very, very straight. I'll put a link to that in the description. And the internal bore size is about 10.5mm, so it's actually a good barrel, but not particularly accurate. So I'm wondering if anyone can give me an explanation about something. This is to do with compressed air tanks exploding when there's oil in them at very high pressure. So if oil vapour comes off the compressor somehow, and you've got this thing up at like say 2000 psi, which I obviously won't do, but it has happened in paintball cylinders where the cylinder is just like started, from the pictures I've seen, started burning like sort of like some sort of thermite or something, or just spontaneously exploding. I don't understand how that can happen, because like in a diesel engine the pressure and temperature rises instantaneously almost in the cylinder, so I don't understand how the oil can detonate inside an air tank when the pressure has been brought up very slowly, because the temperature inside the tank must be nowhere near the ignition temperature of oil, so I don't understand how this could explode in those conditions. Unless maybe there's somehow a spark inside the tank, but if someone could provide an explanation, any other explanations, then I'd be really interested. So here's part of one of those Chinese valves, and the concern I have with these is, like, I'm not running them, I'm not even running this at 200 psi. If I wanted to run this at higher pressure, I'd have to use my refrigeration compressor to fill it, but I don't really want to do that because it does produce oil vapour, and I do not want to risk an explosion. But I don't know what pressure this would withstand before the end pops off it. As you can see, it's press fit on. So this is actually goes inside this solenoid coil, and there's a little plunger thing inside there normally. So I reckon it would probably withstand 800 psi. These valves on the description are usually rated at about, I think, 1 megapascal or something like 140 psi, and I think that's meaning the pressure at which they would open under 12 volts and be able to just function normally. I don't think that means the burst pressure, and sadly the burst pressure isn't mentioned anywhere. But what I'll try and do one day is just get one of these valves on their own and try it with just CO2 from a fire extinguisher and see if it can hold 900 psi or 1000 or whatever it is without leaking. So the gun is filled just from my air compressor. That's it filling up just now. Cannot really hear it. Must have not been that much pressure lost from my tests. So it just runs on a 3-cell LiPo battery, and all you do is just press the button to fire it. And my circuit design only allows it to fire for an instant, even if you keep your finger held on it. And if you release it, I don't know if you heard that, but as you can see, it doesn't let you fire it like loads of times. You have to wait a second between shots. So it's just some sort of feature that I put in, and you just make that capacitor bigger if you wanted the shot time to be longer, time between shots. I haven't figured out just yet how to incorporate another capacitor resistor network to make the valve open for a longer amount of time, but it probably doesn't really need to be, unless the amount of time it's opening just now is probably fine just for much higher pressures, but for lower pressures you'd need the valve to be open longer. So enough of me talking, let's test fire it. Okay, so to fire, pellet just gets put in the back, the plastic one, and we just attach the barrel like this. There we go. So, just a little bit more information about how it's constructed. It's all secured together, all the fittings with this, and that's just to provide the most airtight seals possible, so I can keep air in it for extended periods if I wanted to. This gauge on the bottom is obviously knackered, as you can see. The tank is designed to withstand probably over 2000 psi, and it says it's full at about 200 bar, so it'd be stupid to run that amount of pressure because the valve would just explode probably. I certainly wouldn't want to run it any more than what I was putting in it just now. That's because the oil vapour issue, which I mentioned earlier. Air rifles normally run 900 to 1000 psi, and in some cases I think roughly 2000 psi for the air rifles that actually use air and not carbon dioxide. So I know it's 10.5mm and it's a plastic bullet, but compare that to a small 2.2 pellet being propelled at 1000 psi, which is even heavier than that. This is a toy pea shooter in comparison, really. But it's just mainly to demonstrate sort of the science of how an air gun can be constructed. So I reckon you could get a lot more power out of this, but I don't know what pressure it would actually withstand. That's why I need to test these valves. In fact, there might be a way to hydrostatically test it. If I had some way of pumping, I could connect it up to a pressure washer. I think they can produce some ridiculously high pressures, and if it doesn't explode when connected to the output of a pressure washer, then it's probably going to be fine. So that would actually be a good test, but I would need to source some adapters and whatever to try and connect that to a pressure washer.